Today I'm going to talk a little bit about composite functions. So I'm going to show you a couple of different examples of how to solve this. The first problem I'm going to show you is how to solve it specifically. So in this example we're looking at two functions. F of x equals 3x squared plus 2 and g of x equals the square root of x plus 4. And what I want to find is f of g of 3. What that means is in one approach is I'm going to find out what g of 3 is first and then plug that into f of x. So let's try that approach first. So what I'm going to do is I'm going to start with g of x, which we've already determined is given as x plus 4. And then instead I'm going to put in g of 3. And what that means is wherever there's an x in the function, I'm going to replace it with 3. So watch me do that here. So I'm going to put 3 in for x and the 4 still remains. And so what I get as an answer to this is g of 3 equals the square root of 7. Okay, that's my answer so far. But what I really want is I really want to find what f of g of 3 is. Okay, this is my goal here. I'm trying to get to f of g of 3. Okay, I don't have that quite yet. So what I'm going to do is I'm going to go back to f of x, and f of x is given as 3x squared plus 2. Okay, and this time I'm going to replace x with g of 3. Well, we just found out that g of 3 is the square root of 7. So what I'm going to do is I'm going to replace g of 3 with the square root of 7. So basically what I'm doing is I'm taking the function 3x plus 2 and putting in square root of 7 for it. And so what I get is 3 square root of 7 squared, because it's still squared, that value is still squared, plus 2. Okay? Now, what I know about this is that the square root of 7 squared, whenever you square a square root, it becomes a real number. So what I've got is 3 times 7 plus 2. So my final answer for this equals 21 plus 2, or 23. 23. So my final answer is 23 for this problem. Okay, I hope that helps. I'm going to show you in another example how to solve this by going about another way using composite functions in a generic form first.